Hello everyone, in this tutorial I'm going to be continuing illustrating the project capability of Real-Time Studio. In the previous example we designed this system consisted of two components, producer and consumer, and system description, and then we could synchronize the two components, okay, and then we could generate also state space. Now what I'm going to be doing, I'm going to show you how to synchronize components using their transitions instead of places. Of course you can do both. You can synchronize at the same time using places and transition, but just to make it simple I'm going to be illustrating each concept separately. So for now we're going to be just looking to the transition synchronization. To illustrate this capability I will be adding an extra component, which is going to be the controller. So for now the controller is not going to be done using a variable, but a component called controller. So I'll remove this variable here, and for the producer I will be removing the guard, so it's going to be just, and for the update I don't need it. For the consumer, the same thing. So for the guard it stays true, and for the update I will just remove it. So we have these two components now without the control thing, and now I'm going to be adding a controller component. So this is my control component. I will rename it by just pressing here and press another time, wait a little bit. It's going to be the controller. In the controller we're going to be having a place, which has 5 tokens representing the limit of the buffer, 5 tokens. And then we will be having this transition here, which represents the production operation, and we're going to be having another transition which can correspond to the production. So I will need transition. I would start from transition, press here, that's it. So if I want to flip these transitions I can do it, like select the transition, that will do that. So this transition is going to be called production. I would call it just P to make it easy for production. P or PR, production. And this transition is going to be called consumption. C is consumption, or CO, consumption. Okay. Now we need to do the same thing for this transition. This one corresponds to the production, so I will call it PR. And for the consumer, we're going to be doing the same thing. It's going to be what? It's going to be CO. Then we need to do something extra. To be able to synchronize the places, we're going to tell the system that this action here, or this transition of consumption, is going to be an output action by putting an interrogation mark. So this action is actually generated by the consumer. It's generated by the consumer, and the controller receives it. So to say that this is an input action, so it's going to be an interrogation mark following the name of the thing. The same thing for this transition, it's going to be an input action, so it's a reception of an event if you want, or reception of a message. So the controller will receive a production action, and he will receive a consumption action. So for the producer we have to say that this action here is sending a message, or the action is generated by the producer, so it's going to be an exclamation mark. Okay, so that's it for the three components. Now we need to add another component here, which is going to be process. It's going to be controller, and it's going to be equal to the consumer controller thing, sorry, controller component. It looks like it's fine for now, so let's try to generate the system, and that's it. Now we have the synchronization. It looks a little bit ugly, so I have to bring everything to fit this panel, and let's see if we get the same thing as before. This is the producer, this is P1, this is the consumer, and as you can see, it is exactly what I wanted. We have a producer, consumer. Let's see, the synchronization is okay, and let's see if so here we synchronized both the production action and the consumption action, and also this place. Okay, so now we have the system, and we can generate state spaces if you want. We can also simulate the system if you want to. We can. So I have to press here and stretch the system, and then we are in this state, and then we can fire transitions. Then we can also fire this one again, and select it, and fire this one again, select it, and so forth. Actually, just before finishing, I want to show you another project which is supplied with a tool. So we're going to be opening it from directory where the application is supposed to be installed. So it's supposed to be in temp, this one here, examples, train. Okay, so here we have a serious example with this level crossing system. We have three components. We have the just to close these things. We have the system description. We have the barrier. We have the train, and we have the controller model. And something which I didn't show you in the previous thing is that for a certain component, we can have also parameters. Like in this example here, M is a parameter. How can we specify parameters in a component? If you go to the attribute viewer for the Petri net, we can see that here we have a parameter of type integer. So it's like this is a function, and function takes parameter, and the parameter is M here. And the parameter can be used in to set the label for or the number of tokens for the places, or even for these links here. And then in the system description, you can supply the parameter value. In this example, we're using a variable called k, and we're setting it as a parameter for the controller. And here it's going to be in this system description, we have just two trains. We want to synchronize two instances of the train, and one instance of the controller, and one barrier. So if you compile, you get this thing here. It's the system synchronization. And by a simple thing, if we want to have 3 or 4 trains, let's say 4 trains here, so I'm going to be just adding 2 extra trains to have a system where, so this is train 3, this is train 2, and that's it. So now if we synchronize, so here it's train 2, it's train 4, okay, because when I tried to compile I got duplicate definition of train 2. So when we synchronize, we get these things. It looks very ugly anyway. So we bring everything together here. And then we have 4 trains. They are all synchronized with the controller. And then we can generate state space for the thing and everything. We can simulate, we can do everything. So that's it for the synchronization part of these list of videos, and thank you for watching.